Hello there, and welcome to The Weary Researcher. I'm so grateful you found your way here tonight, to this quiet corner of the internet where we explore the most extraordinary possibilities that science has to offer. Whether you're settling in for the evening, wrapped in your favourite blanket, or simply letting your mind wander through the cosmos of human knowledge, you've arrived at just the right moment. Tonight, we're embarking on what might be the most mind-bending journey we've ever taken together. We're going to explore two phenomena that sound like pure science fiction, but are actually grounded in the most rigorous physics imaginable. We're talking about instant teleportation and faster-than-light travel. Not the Hollywood versions, mind you, but the real scientific breakthroughs that are happening right now in laboratories around the world. Before we drift into this fascinating exploration, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something beautifully fitting about discussing instantaneous communication while we're all scattered across different time zones, each experiencing this moment from our own unique perspective. If you find these gentle journeys through cutting-edge science as captivating as I do, I'd be ever so grateful if you gave this video a like and perhaps subscribed to the channel. It helps more curious minds like yours discover these peaceful explorations of the extraordinary. Now, I should give you a gentle warning before we begin. This topic might be just fascinating enough to keep you wide awake well past your intended bedtime. But if you do find yourself lying there at 2 a.m, contemplating the nature of quantum entanglement and warp drives, well, at least you'll have learned something absolutely remarkable about the cutting edge of human understanding. So take a deep breath, let your shoulders relax, and prepare to have your understanding of what's possible gently turned upside down. Because what we're about to explore isn't just theoretical anymore. Scientists have actually achieved quantum teleportation, and they're making serious progress toward technologies that could one day carry us to the stars faster than light itself. Picture this for a moment. You're holding your phone, perhaps reading a message from someone on the other side of the world. That message travelled to you at the speed of light through fibre optic cables, bouncing between cell towers and satellites in a journey that took mere milliseconds. It seems instantaneous, but it's not quite. There's still that fundamental limit, that cosmic speed restriction that governs how quickly information can travel through our universe. But what if I told you that scientists have found a way around that limit? What if information could be transferred not just faster than light, but truly instantaneously, with zero delay regardless of distance? And what if the same principles that make this possible could eventually carry spacecraft to distant stars in the blink of an eye? This isn't science fiction, this is quantum teleportation, and it's one of the most profound breakthroughs in modern physics. Just this year, researchers at Northwestern University achieved something that many thought was impossible. They successfully demonstrated quantum teleportation over fibre optic cables that were simultaneously carrying regular internet traffic. Imagine that. While your emails and videos were flowing through those cables at the speed of light, quantum information was being teleported instantaneously through the very same infrastructure. The lead researcher, Professor Prem Kumar, said something that perfectly captures the magnitude of this achievement. This is incredibly exciting because nobody thought it was possible. And he's right. For decades, scientists believed that the delicate quantum states required for teleportation would be completely overwhelmed by the cacophony of classical data streaming through modern internet cables. It would be like trying to hear a whisper in the middle of a rock concert. But they found a way. They discovered how to protect those impossibly fragile quantum states, how to guide single photons through what one researcher described as massive trucks in an underground tunnel. They made the impossible possible, and in doing so, they've opened the door to a quantum internet that could operate alongside our existing digital infrastructure. Now let's be clear about what quantum teleportation actually is, because it's both more and less magical than you might imagine. When we say teleportation, we're not talking about Star Trek transporters that disintegrate you in one place and reconstruct you in another. We're talking about something far more subtle and, in many ways, far more profound. Quantum teleportation is the instantaneous transfer of quantum information from one location to another, regardless of the distance between them. The key word here is information. We're not moving particles through space at faster than light speeds. Instead, we're transferring the quantum state of one particle to another particle that might be on the other side of the galaxy. It works through a phenomenon that Einstein himself called spooky action at a distance, though he wasn't entirely comfortable with its implications. When two particles become quantum entangled, they form a connection that transcends space and time. Measure one particle, and you instantly know something about its partner, no matter how far apart they are. Change the state of one, and its entangled partner responds immediately. This isn't just theory anymore. Researchers have demonstrated quantum entanglement across distances of hundreds of kilometers, and they've used this phenomenon to teleport quantum information with remarkable success. The process is elegant in its complexity. You take a particle, whose quantum state you want to teleport, you entangle it with one half of an entangled pair, and then you perform what's called a Bell measurement. This measurement destroys the original quantum state while simultaneously transferring it to the distant particle. The implications are staggering. Imagine communication networks that are absolutely secure, where any attempt at eavesdropping would be immediately detected because it would disturb the delicate quantum states. Imagine quantum computers distributed across the globe, working together on problems too complex for any single machine to solve. Imagine a quantum internet where information travels not through cables and radio waves, but through the fundamental fabric of reality itself. But here's where things get even more interesting. The same quantum mechanical principles that enable teleportation might also hold the key to faster-than-light travel. Not the teleportation of information this time, but the transportation of matter itself across vast distances in ways that seem to violate everything we thought we knew about the speed of light. The speed of light has long been considered the ultimate cosmic speed limit. Einstein's special theory of relativity tells us that as objects with mass approach the speed of light, their energy requirements become infinite. It's not just difficult to reach light speed with conventional propulsion, it's impossible. The universe itself seems to conspire against faster-than-light travel. But what if we're thinking about this all wrong? What if instead of trying to push objects faster through space, we manipulated space itself? This is the insight that led theoretical physicist Miguel Alcubierre to propose one of the most elegant solutions to faster-than-light travel ever conceived. In 1994, Alcubierre published a paper that would forever change how we think about interstellar travel. He realized that while Einstein's relativity forbids objects from moving faster than light through space, it says nothing about space itself expanding or contracting faster than light. In fact, we know this happens. During the early moments of the Big Bang, space itself expanded faster than light could travel through it. Alcubierre's insight was beautifully simple. Instead of accelerating a spacecraft to impossible speeds, why not create a bubble of warped spacetime around it? Contract space in front of the ship, expand space behind it, and let the bubble carry the vessel along like a surfer riding a wave. The spacecraft never exceeds the speed of light within its local reference frame, but the bubble itself could travel faster than light, carrying its contents to distant stars in a matter of days or weeks instead of millennia. The mathematics work out perfectly. The Alcubierre drive doesn't violate relativity, it harnesses it. The crew experiences no acceleration, no time dilation, no uncomfortable side effects. From their perspective, they're sitting perfectly still while the universe flows past them. It's space itself that does all the work, folding and stretching to bring distant destinations closer. But of course there's a catch. There's always a catch when we're dealing with physics at the very edge of possibility. The original Alcubierre drive required something called exotic matter, matter with negative energy density. This isn't just rare or expensive, it might not exist at all in our universe. The energy requirements were astronomical, literally requiring the mass energy equivalent of entire planets or stars. For years, this seemed to relegate the Alcubierre drive to the realm of interesting theoretical curiosities. But then something remarkable happened. Scientists began finding ways to dramatically reduce those energy requirements. Dr. Harold Sonny White at NASA proposed modifications to the warp bubble geometry that could bring the energy requirements down from impossible to merely extremely challenging. More recently, Dr. Eric Lentz at the University of Göttingen published research suggesting that warp drives might not require exotic matter at all. His calculations show that certain configurations of conventional matter and energy could create warp-like effects, potentially bringing faster-than-light travel within the realm of advanced but achievable technology. NASA has taken these ideas seriously enough to fund actual research. They've built what they call the White-Jude Warp Field Interferometer, a device designed to detect and measure tiny distortions in spacetime. While they haven't created a working warp drive yet, they're developing the tools and techniques that might one day make it possible. The implications of successful warp drive technology would be revolutionary beyond imagination. Suddenly, the nearest star system wouldn't be 4 years away at light speed, but perhaps weeks or months with a warp drive. The galaxy wouldn't be a collection of isolated islands separated by impossible gulfs of space and time, but a neighborhood where worlds and civilizations could actually communicate and interact. But let's step back for a moment and consider what's already happening in laboratories around the world. Because while warp drives remain theoretical, quantum teleportation is happening right now, and it's advancing at an incredible pace. Researchers at the University of Turku in Finland and the University of Science and Technology of China made a breakthrough that seemed to defy conventional wisdom. They discovered that certain types of noise, which traditionally disrupts quantum systems, can actually enhance the quality of quantum teleportation. What was once considered harmful interference became beneficial assistance, improving the fidelity of quantum state transfer even in challenging environments. This is huge. One of the biggest obstacles to practical quantum communication has been the fragility of quantum states. They're easily disrupted by thermal noise, electromagnetic interference, and countless other environmental factors. But if noise can actually help instead of hinder quantum teleportation, it opens up possibilities for quantum communication in real-world conditions that previously seemed impossible. Meanwhile, researchers at Oxford University achieved another quantum milestone. They successfully linked two independent quantum processors using quantum teleportation, effectively creating a single, larger quantum computer. This isn't just an academic achievement. It's a glimpse into the future of quantum computing, where networks of quantum processors work together on problems too complex for any individual machine. The quantum teleportation protocol they used doesn't just transfer quantum states, it transfers quantum logic operations themselves. Imagine being able to run parts of a quantum algorithm on processors located anywhere in the world, with the results teleported instantaneously between them. The computational possibilities are breathtaking. But perhaps the most exciting development is the integration of quantum teleportation with existing internet infrastructure. The Northwestern University breakthrough proves that quantum and classical communications can coexist in the same fiber optic cables. This means the quantum internet of the future won't require completely new infrastructure. It can be built on top of what we already have. Think about what this means for the timeline of quantum technology deployment. Instead of waiting decades to build dedicated quantum communication networks, we might see quantum-secured internet connections much sooner. banks could use quantum encryption to protect financial transactions. Governments could secure classified communications with quantum keys that are physically impossible to intercept without detection. The technical challenges remain formidable, of course. Quantum states are incredibly delicate, and maintaining them over long distances requires extraordinary precision. Current quantum teleportation experiments work over distances of kilometers or tens of kilometers. Scaling to intercontinental distances will require quantum repeaters, devices that can extend quantum entanglement across vast networks without destroying the quantum information they're designed to preserve. But the progress is accelerating. What seemed impossible just a few years ago is now routine in advanced physics laboratories. Quantum teleportation distances are increasing, fidelity is improving, and the technology is becoming more robust and practical with each breakthrough. The connection between quantum teleportation and faster-than-light travel isn't immediately obvious, but it's profound. Both phenomena challenge our intuitive understanding of space, time, and causality. Both suggest that the universe is far stranger and more malleable than our everyday experience would suggest. Quantum teleportation shows us that information can transcend the normal limitations of space and time. It can be transferred instantaneously across any distance, limited not by the speed of light but by the speed of quantum entanglement, which appears to be truly instantaneous. Warp drive research suggests that matter itself might be able to circumvent the cosmic speed limit, not by moving faster through space, but by manipulating the structure of space itself. Both quantum teleportation and warp drive technology work by exploiting loopholes in our understanding of physics, finding ways to achieve seemingly impossible results without actually violating the fundamental laws of nature. As we continue our exploration of these remarkable phenomena, we'll discover how recent breakthroughs in quantum physics are bringing us closer to practical applications that once seemed purely theoretical. We'll examine the latest research in warp drive physics, including NASA's ongoing investigations and the revolutionary new approaches that eliminate the need for exotic matter. We'll also explore the profound implications of these technologies for human civilization. What would society look like with instant quantum-secured communication networks? How would faster-than-light travel change our relationship with the cosmos? And what challenges and opportunities would these technologies create for future generations? The journey we're embarking on tonight will take us from the quantum realm, where particles exist in multiple states simultaneously, to the cosmic scale, where space and time themselves become malleable. It's a journey that reveals the universe to be far more mysterious and wonderful than we ever imagined, full of possibilities that stretch the boundaries of human comprehension. So settle in comfortably, let your mind open to these extraordinary possibilities, and prepare to explore the cutting edge of human knowledge. Because what we're about to discover together isn't just about teleportation and faster-than-light travel. It's about the fundamental nature of reality itself and our growing ability to harness the deepest mysteries of the universe for the benefit of all humanity. The future is arriving faster than we ever thought possible, and it's more amazing than we ever dared to dream. The quantum realm operates by rules so fundamentally different from our everyday experience that even the most brilliant physicists sometimes struggle to accept its implications. When we peer into this microscopic world, we discover phenomena that seem to mock our common sense understanding of reality. Particles exist in multiple states simultaneously until observed. Information can be shared instantaneously across infinite distances, and the very act of measurement changes the nature of what we're trying to measure. It's in this strange quantum landscape that some of the most profound breakthroughs in teleportation research are occurring. Scientists have discovered that the quantum world doesn't just permit instantaneous information transfer, it practically demands it. When two particles become entangled, they don't just share a connection, they become aspects of a single quantum system that transcends our normal concepts of space and separation. Recent experiments have pushed the boundaries of what we thought possible with quantum teleportation. Researchers have successfully maintained quantum entanglement while one particle travels through busy fiber optic networks filled with classical internet traffic. Think of it like maintaining a delicate conversation in a bustling marketplace. The quantum information, carried by single photons, somehow navigates through millions of classical light particles without losing its coherence or its connection to its distant partner. The technical achievement here cannot be overstated. Classical communications use millions of light particles streaming through fiber optic cables like a highway packed with traffic. Quantum communications, by contrast, rely on individual photons, single particles of light, carrying quantum information in their polarization states. Getting these solitary quantum messengers through the classical traffic was like threading a needle while riding a roller coaster in the dark. But the researchers found a way. They discovered specific wavelengths where quantum photons could travel alongside classical data without interference. They developed techniques to protect these fragile quantum states from the electromagnetic noise that fills our modern communication networks. Most remarkably, they proved that quantum and classical information could not just coexist, but actually complement each other in ways that enhance the overall communication system. This breakthrough opens up extraordinary possibilities for near-term applications. Instead of building entirely separate quantum communication networks, we might integrate quantum capabilities into our existing internet infrastructure. Your home internet connection could carry both your streaming video and quantum encrypted communications simultaneously. Banks could secure financial transactions with quantum keys while still providing normal online banking services through the same cables. The security implications alone are revolutionary. Quantum encryption doesn't just make communications difficult to intercept, it makes interception physically detectable. Any attempt to eavesdrop on quantum encrypted information would disturb the quantum states involved, immediately alerting both sender and receiver to the security breach. It's like having a lock that not only prevents unauthorized access, but also leaves unmistakable evidence of any tampering attempt. But quantum teleportation research has revealed something even more remarkable about the nature of information itself. Scientists working with multipartite hybrid entanglement have discovered that certain types of environmental noise, traditionally considered harmful to quantum systems, can actually improve the quality of quantum teleportation. What was once seen as interference became assistance, transforming the quantum communication process in unexpected ways. This discovery fundamentally changes how we think about quantum systems in the real world. Instead of requiring perfectly isolated laboratory conditions, quantum teleportation might work better in noisy, chaotic environments. The universe itself might be providing assistance for quantum communication in ways we're only beginning to understand. The implications extend far beyond communication networks. If quantum systems can harness environmental noise rather than being destroyed by it, quantum computers might operate effectively in conditions previously thought impossible. Quantum sensors could work in challenging industrial environments, and quantum teleportation networks could span continents without requiring the pristine conditions once thought necessary. Meanwhile, researchers at Oxford University achieved another quantum milestone that brings us closer to practical quantum computing networks. They successfully teleported not just quantum information, but quantum logic operations themselves between separate quantum processors. This isn't merely transferring data from one computer to another, it's sharing computational processes across distributed quantum systems. Imagine running a complex calculation where different parts of the algorithm execute on quantum processors located around the world, with results teleported instantaneously between them. The computational power available through such networks would dwarf anything achievable with individual quantum computers, no matter how large or sophisticated. This distributed approach, also solves one of quantum computing's biggest challenges: scaling. Building a quantum computer with millions of qubits in a single device presents enormous technical difficulties. But networking smaller quantum processors through quantum teleportation could achieve the same computational power without requiring impossibly complex single devices. It's like solving a problem by connecting many smaller solutions rather than building one massive machine. The quantum teleportation process itself reveals profound insights about the nature of information and reality. When quantum information is teleported, the original quantum state is destroyed in the process. This isn't copying information, it's genuinely moving it from one location to another. The no-cloning theorem of quantum mechanics ensures that quantum information cannot be duplicated, only transferred. This has fascinating implications for our understanding of identity and continuity. If consciousness operates through quantum processes, as some researchers propose, then quantum teleportation might offer insights into questions about personal identity that have puzzled philosophers for centuries. Could conscious experience itself be teleported from one substrate to another? The questions stretch far beyond physics into the deepest mysteries of mind and identity. But let's return to the realm of faster-than-light travel, where recent theoretical breakthroughs have brought seemingly impossible concepts closer to practical reality. The Alcubierre warp drive, once requiring the energy equivalent of entire planets, has undergone radical refinements that dramatically reduce its energy requirements. Dr. Eric Lentz's recent research proposes warp drive configurations that eliminate the need for exotic matter entirely. Instead of requiring materials with negative energy density, his models use sophisticated arrangements of conventional matter and energy to create spacetime distortions. While the energy requirements remain enormous by current standards, they've dropped from impossible to merely extremely challenging. The key insight involves creating what physicists call solitons, stable wave-like distortions in spacetime that maintain their shape while propagating faster than light. These aren't science fiction concepts, but legitimate solutions to Einstein's field equations. They represent regions where space itself becomes structured in ways that permit effective faster-than-light travel without violating relativistic constraints. NASA's Eagle Works laboratory has been quietly investigating these concepts through careful experimental work. Their White Jude warp field interferometer uses sophisticated laser interferometry to detect microscopic distortions in spacetime. While they haven't created a working warp drive, they're developing the measurement techniques and theoretical understanding that might eventually make such technology possible. The approach involves creating carefully controlled electromagnetic fields in specific geometric configurations, then measuring whether these fields produce detectable spacetime curvature. It's painstaking work, requiring extraordinary precision and patience, but it represents the first serious experimental investigation of warp drive physics using actual hardware rather than purely theoretical calculations. Recent refinements to warp drive theory have focused on optimizing the geometry of the warp bubble itself. Instead of the original ring-shaped configuration proposed by Alcubierre, newer models explore toroidal and other complex geometries that might be more energy efficient. Some configurations could reduce energy requirements by orders of magnitude while maintaining the essential faster-than-light capability. The energy sources for such drives remain a significant challenge. Even the most optimized warp drive designs require power outputs comparable to large nuclear reactors. But fusion technology is advancing rapidly, and theoretical concepts like antimatter annihilation could provide the energy densities necessary for warp drive operation. What seems impossible today might become merely expensive tomorrow. Other theoretical approaches to faster-than-light travel explore different aspects of spacetime manipulation. Traversable wormholes, shortcuts through higher dimensional space, could connect distant regions of the universe without requiring faster-than-light travel through normal space. While creating stable wormholes presents its own challenges, the physics permits their existence under certain conditions. The relationship between quantum mechanics and general relativity becomes crucial in these extreme scenarios. Quantum effects might naturally create the exotic conditions required for warp drives or stable wormholes. The quantum vacuum itself, far from being empty space, seethes with virtual particles and energy fluctuations that might be harnessed for spacetime manipulation. The Casimir effect demonstrates that quantum vacuum energy can produce measurable forces between conducting plates. Scaling this effect up to create the negative energy densities required for warp drives remains highly speculative, but it provides a potential pathway from laboratory physics to revolutionary propulsion technology. As we explore these possibilities, it's important to recognize that we're not just discussing transportation technology. We're contemplating fundamental changes to humanity's relationship with space and time. Instant quantum communication and faster-than-light travel would reshape civilization in ways we can barely imagine. Consider the implications for human consciousness and identity. If quantum teleportation can transfer information instantaneously across any distance, and if consciousness involves quantum processes, then the boundaries between individual minds might be more fluid than we assume. Quantum communication networks could enable new forms of collective intelligence and shared experience. Similarly, faster-than-light travel would transform our species from a single-planet civilization into a truly galactic one. The nearest star systems would become accessible within human lifetimes. The galaxy would shrink from an impossibly vast wilderness into an explorable frontier. Humanity could spread among the stars while maintaining real-time communication across interstellar distances. But these technologies also raise profound questions about causality and the nature of time itself. If information can travel faster than light, then under certain conditions, it might arrive before it was sent. This creates potential paradoxes that challenge our understanding of cause and effect. The universe might have built-in protection mechanisms against such paradoxes, or it might permit them in ways that reveal deeper truths about the nature of time. The research continues in laboratories around the world, pushing the boundaries of what we thought possible. Each breakthrough brings us closer to technologies that will transform human civilization. Each discovery reveals new aspects of a universe far stranger and more malleable than our ancestors ever imagined. We stand at the threshold of an age where the impossible becomes merely improbable, where the fundamental forces of nature become tools for transcending the limitations that have confined humanity to a single world and a single moment in cosmic time. The journey we're taking together through these concepts isn't just about understanding new physics, it's about glimpsing the extraordinary future that awaits us among the stars. The exploration of these advanced propulsion concepts has led researchers down some truly unexpected pathways, each revealing new facets of our universe's hidden architecture. One of the most intriguing developments involves the study of gravitational waves and their relationship to theoretical warp drive physics. When massive objects accelerate through spacetime, they create ripples in the fabric of reality itself, and these gravitational waves carry information about the events that created them. Researchers have begun using sophisticated computer simulations to model what would happen if a warp drive experienced what they call a containment failure. The results are fascinating and potentially revolutionary. A collapsing warp bubble would generate a distinctive pattern of gravitational waves, a unique signature that could be detected by our most sensitive instruments. This isn't just academic curiosity, it represents a potential method for detecting advanced propulsion systems, whether created by human technology or perhaps by civilizations far more advanced than our own. Dr. Katie Clough of Queen Mary University of London, who led this research, explained that even purely theoretical technologies like warp drives, have well-defined descriptions in Einstein's theory of general relativity. This means we can use numerical simulations to explore their impact on spacetime itself. The gravitational wave signatures they've calculated could be distinguished from natural astrophysical events like black hole collisions or neutron star mergers. Imagine the implications of this discovery. If we ever detect gravitational waves with the distinctive pattern of a warp drive collapse, we would know that somewhere in our galaxy, intelligent beings have mastered faster-than-light travel. It would be the first concrete evidence that such technology is not only possible, but actually in use. The universe might already be filled with the gravitational echoes of interstellar civilizations, signatures we're only now learning to recognize. This gravitational wave research has also revealed something unexpected about the nature of spacetime itself. The simulations show that warp bubbles interact with the quantum foam that underlies all of space and time in ways that could amplify certain quantum effects. This interaction might provide a natural mechanism for stabilizing warp drives, using the universe's own quantum infrastructure to maintain the exotic spacetime configurations required for faster-than-light travel. The quantum foam, that seething ocean of virtual particles that exists at the smallest scales of reality, might not be an obstacle to warp drive technology, but rather an essential component. Just as quantum teleportation harnesses the strange properties of entangled particles, warp drives might harness the equally strange properties of quantum spacetime to achieve their remarkable effects. This brings us to another fascinating aspect of cutting-edge physics research, a class of hypothetical particles called tachyons. These theoretical entities would always travel faster than light, existing in a realm where faster motion requires less energy rather than more. While no tachyons have ever been detected, recent theoretical work has shown that they might not violate the principles of special relativity as previously thought. Researchers from the University of Warsaw and the University of Oxford published groundbreaking work showing that many of the objections to tachyons were based on misunderstandings of relativistic causality. Tachyons might actually help us understand the causal structure of spacetime better, revealing new possibilities for faster-than-light phenomena that don't create the paradoxes once thought inevitable. The mathematics of tachyons suggest they would possess imaginary mass values, a concept that sounds absurd but makes perfect sense within the framework of complex number theory. Just as imaginary numbers proved essential for understanding quantum mechanics, imaginary mass might be the key to understanding faster-than-light physics. These particles would inhabit a mirror image of our familiar world, where the roles of space and time become interchanged in subtle but profound ways. If tachyons exist, they could provide a natural mechanism for faster-than-light communication that doesn't require the enormous energy expenditures of warp drives. Tachyonic communication systems might operate by modulating streams of these faster-than-light particles, creating information channels that transcend the normal limitations of electromagnetic radiation. The search for tachyons has led to some of the most sensitive experiments in modern physics. Researchers use particle accelerators to create conditions where tachyons might be produced, looking for signatures of particles that arrive before they're created. While these searches haven't succeeded yet, they're pushing the boundaries of experimental technique and revealing new aspects of high-energy physics. Meanwhile, the quantum teleportation research continues to yield surprising results about the fundamental nature of information itself. Scientists have discovered that quantum information can be stored in systems that exist in multiple locations simultaneously, creating what they call distributed quantum memories. These systems could serve as waypoints for long-distance quantum teleportation, extending the range of quantum communication networks far beyond what seemed possible just a few years ago. The distributed memory systems work by creating quantum entanglement between multiple storage devices, allowing quantum information to exist in a superposition of being stored in several locations at once. When the information is retrieved, it collapses into a definite state at one location while disappearing from all others. It's like having a library book that exists on multiple shelves simultaneously until someone checks it out. This distributed approach solves one of the biggest challenges in quantum communication, the problem of quantum error correction over long distances. Traditional error correction requires multiple copies of information, but quantum mechanics forbids perfect copying of quantum states. Distributed quantum memories provide a way around this limitation, using the strange properties of quantum superposition to protect information without violating the no-cloning theorem. The applications extend far beyond communication networks. Distributed quantum computing could allow calculations to be performed across multiple quantum processors simultaneously, with the computational load shared among systems that might be separated by vast distances. The results would be teleported between processors as needed, creating computational networks that operate at the speed of quantum entanglement rather than the speed of light. Recent experiments have demonstrated quantum teleportation between different types of quantum systems, transferring information from photons to atoms to solid-state devices. This versatility suggests that quantum teleportation could serve as a universal interface between different quantum technologies, allowing diverse systems to communicate and share information seamlessly. The implications for quantum computing are particularly exciting. Different quantum technologies excel at different tasks. Photonic systems are excellent for communication, atomic systems are superb for precision measurements, and solid-state systems offer the potential for large-scale integration. Quantum teleportation could allow these different approaches to work together, combining their strengths while minimizing their individual limitations. The energy requirements for quantum teleportation remain remarkably modest compared to theoretical, faster-than-light propulsion systems. A typical quantum teleportation experiment requires only the energy needed to generate and detect single photons, amounts so small they're barely measurable with conventional instruments. This efficiency suggests that quantum communication networks could operate with power requirements similar to existing internet infrastructure. But the true elegance of quantum teleportation lies not in its energy efficiency, but in its fundamental security. The laws of quantum mechanics themselves protect quantum encrypted communications from interception. Any attempt to measure or copy quantum information necessarily disturbs it, creating detectable changes that alert the communicating parties to the presence of an eavesdropper. This quantum security isn't just theoretical, it's been demonstrated in real-world conditions. Quantum key distribution systems are already in commercial use, protecting sensitive communications with security guaranteed by the fundamental laws of physics, rather than just mathematical complexity. As quantum teleportation technology matures, these security advantages will extend to more sophisticated forms of quantum communication. The relationship between quantum teleportation and consciousness continues to intrigue researchers at the intersection of physics and neuroscience. If the brain operates as a quantum computer, as some theories suggest, then quantum teleportation might offer insights into the nature of consciousness itself. Could conscious experiences be transferred between different substrates? Could memories be teleported from one mind to another? These questions push us toward philosophical territory that would have seemed like pure fantasy just decades ago. But as our understanding of quantum mechanics deepens and our ability to manipulate quantum systems improves, such speculations become less fantastical and more scientifically grounded. The universe, it seems, is far stranger and more malleable than our everyday experience would suggest. The convergence of quantum teleportation research and faster-than-light travel theories reveals something profound about the nature of reality itself. Both phenomena suggest that the limitations we observe in our everyday world, the speed of light the locality of interactions, the irreversibility of information transfer might be emergent properties of a deeper reality that operates according to very different rules. At the quantum level, particles exist in superposition states that transcend our normal concepts of location and identity. Information can be shared instantaneously across arbitrary distances. The very act of observation changes the nature of what we're observing. These aren't glitches in our understanding. They're fundamental features of reality that we're only beginning to appreciate. As we continue our exploration of these remarkable phenomena, we'll discover how recent breakthroughs are bringing us closer to practical applications that could transform human civilization. The quantum internet might arrive sooner than anyone expected, riding on the infrastructure we've already built. Faster than light travel, while still challenging, appears less impossible with each theoretical breakthrough. The future we're approaching is one where distance becomes less meaningful, where information travels at the speed of thought rather than the speed of light, where the barriers that have confined humanity to a single world begin to dissolve. It's a future that challenges our most basic assumptions about space, time, and the nature of existence itself. We stand at the threshold of discoveries that will reshape not just our technology, but our understanding of what it means to be conscious beings in a quantum universe. The journey we're taking together through these concepts reveals a cosmos far more interconnected and responsive than we ever imagined. A universe where consciousness and physical reality dance together in ways that blur the boundaries between mind and matter, between the possible and the actual. The gentle rhythm of scientific progress continues, each breakthrough building upon the last, each discovery opening new pathways toward a future where the impossible becomes inevitable. In the quiet laboratories where these experiments unfold, researchers are not just pushing the boundaries of human knowledge, they're laying the groundwork for technologies that will carry our species beyond every limitation we once thought absolute. The gentle hum of quantum computers working in laboratories across the world represents something far more profound than mere technological advancement. These machines, cooled to temperatures colder than the depths of space itself, are quietly rewriting the rules of computation in ways that bring us ever closer to practical quantum teleportation networks. Each qubit they manipulate exists in that strange quantum realm where the normal rules of logic dissolve into probability clouds of infinite possibility. What makes these quantum computers so remarkable for teleportation research isn't just their ability to process information, but their capacity to maintain and manipulate the delicate quantum states that make instantaneous information transfer possible. Unlike classical computers that work with definitive bits of information, quantum computers dance with uncertainty, holding multiple possible answers simultaneously until the moment of measurement collapses them into reality. Recent developments in quantum error correction have solved one of the most persistent challenges facing quantum teleportation networks. Quantum information is extraordinarily fragile, easily disrupted by the slightest environmental interference. But researchers have discovered techniques that protect quantum states without destroying their essential quantum properties, using the strange logic of quantum mechanics to create error correction codes that work with uncertainty rather than against it. The breakthrough came from recognizing that quantum errors don't behave like classical errors. Instead of simply corrupting information, quantum errors create complex patterns of correlation between different parts of a quantum system. By carefully monitoring these correlations, scientists can detect and correct errors without ever directly measuring the quantum information itself. It's like healing a patient without ever touching them, working instead with the subtle influences that connect all quantum systems. This advance has profound implications for long-distance quantum communication. Previously, quantum teleportation was limited to relatively short distances because quantum states would degrade too quickly to maintain their coherence over longer paths. But with robust error correction, quantum information can now travel through networks of quantum repeaters, each one refreshing and protecting the quantum states as they journey toward their destination. The quantum repeaters themselves represent marvels of engineering precision. These devices must capture incoming quantum states, store them in quantum memories, and then re-emit them with perfect fidelity, all while maintaining the delicate entanglement relationships that make teleportation possible. It's like catching butterflies in flight and releasing them unharmed, except the butterflies exist in multiple locations simultaneously, and any disturbance would cause them to vanish entirely. Each quantum repeater extends the range of quantum teleportation networks by roughly a factor of 10, transforming what was once a laboratory curiosity into a technology capable of spanning continents. The first intercontinental quantum teleportation experiments are already being planned using networks of ground-based repeaters and quantum satellites to create communication links that stretch across oceans and time zones. The quantum satellites themselves open up extraordinary possibilities for global quantum communication. Free from the noise and interference that plague terrestrial networks, these orbital platforms can maintain quantum entanglement over thousands of kilometers of empty space. China's Mikius quantum satellite has already demonstrated quantum teleportation from space to ground, proving that quantum communication can work through the Earth's atmosphere despite the turbulence and absorption that affect other forms of optical communication. But perhaps the most exciting development is the integration of quantum teleportation with emerging artificial intelligence systems. Machine learning algorithms are beginning to optimize quantum communication protocols in real time, adapting to changing network conditions and finding more efficient ways to route quantum information through complex networks. These AI systems don't just manage quantum networks, they enhance them, discovering new techniques for preserving and manipulating quantum states that human researchers hadn't considered. The synergy between artificial intelligence and quantum physics creates feedback loops of accelerating capability. AI systems use quantum computers to enhance their own processing power, while quantum computers use AI algorithms to improve their own error correction and state preparation. It's a partnership that promises to unlock capabilities neither technology could achieve alone, bringing us closer to practical quantum teleportation networks that operate with unprecedented reliability and efficiency. Meanwhile, theoretical physicists continue refining our understanding of the fundamental principles that make faster-than-light travel possible. The mathematical frameworks describing warp-drive physics have evolved far beyond Alcubierre's original proposal, incorporating insights from string theory, loop quantum gravity, and other approaches to quantum geometry. These new models suggest that spacetime itself might be more malleable than Einstein ever imagined. One particularly promising approach involves what researchers call metamaterial spacetime engineering. Just as optical metamaterials can bend light in impossible ways, creating invisibility cloaks and perfect lenses, spacetime metamaterials might bend the fabric of reality itself. These aren't physical materials in the conventional sense, but carefully orchestrated patterns of energy and matter that create regions where the normal relationships between space, time, and causality break down in precisely controlled ways. The engineering challenges are formidable, requiring control over matter and energy at scales ranging from the subatomic to the cosmic. But the theoretical foundations are surprisingly solid, built on the same mathematical principles that describe the behavior of black holes, the expansion of the universe, and the quantum vacuum itself. What once seemed like pure fantasy is gradually revealing itself to be an inevitable consequence of the universe's deepest symmetries. Recent computer simulations have modeled the formation and stability of microscopic warp bubbles, regions of curved spacetime just a few nanometers across. While these bubbles are far too small to transport anything larger than individual atoms, They represent proof of principle that spacetime can indeed be manipulated in the ways that warp drive theory requires. Scaling these effects up to macroscopic sizes remains an enormous challenge, but the fundamental physics appears to permit it. The energy requirements for warp drive technology continue to decrease as theoretical understanding improves. What once required the mass energy of Jupiter has been reduced to requirements comparable to large power plants, still enormous by current standards, but no longer fundamentally impossible. Some of the most recent calculations suggest that clever engineering might reduce the energy requirements even further, potentially bringing warp drive technology within reach of advanced civilizations. The connection between quantum mechanics and spacetime curvature becomes crucial at these energy scales. The quantum vacuum, far from being empty space, seethes with virtual particles and energy fluctuations that might be harnessed to create the exotic conditions required for warp drive operation. Recent experiments with the Casimir effect have demonstrated that quantum vacuum energy can indeed produce measurable forces, suggesting pathways from laboratory physics to revolutionary propulsion technology. But the implications of these technologies extend far beyond transportation and communication. They challenge our most fundamental assumptions about the nature of reality itself. If information can be teleported instantaneously across arbitrary distances, what does that say about the structure of space and time? If matter can be transported faster than light without violating physical laws, what does that reveal about the true nature of the universe we inhabit? These questions push us toward a new understanding of consciousness and its relationship to physical reality. Some researchers propose that consciousness itself might operate through quantum processes that transcend the normal limitations of space and time. If this is true, then quantum teleportation might offer insights into the deepest mysteries of mind and identity, suggesting that the boundaries between individual consciousnesses might be more fluid than we typically assume. The possibility that consciousness could be transferred or shared through quantum channels opens up extraordinary speculations about the future of human experience. Could memories be teleported from one mind to another? Could conscious experiences be backed up, stored and retrieved like digital files? Could multiple minds merge into collective intelligences that operate across vast distances through quantum entanglement? While these ideas remain highly speculative, they're grounded in serious scientific research into the quantum foundations of neural processing. The human brain contains structures that operate at temperatures and scales where quantum effects become significant. Microtubules within neurons might function as quantum computers, processing information in ways that transcend classical logic. If consciousness really does depend on quantum processes, then the technologies we're developing for quantum communication might eventually apply to consciousness itself. The social and philosophical implications are staggering. A world with instant, quantum-secured communication would operate according to very different principles than our current reality. Distance would become less meaningful, privacy would require redefinition, and the nature of individual identity might need fundamental reconsideration. When information can be shared instantaneously across any distance, the boundaries that separate different communities, cultures, and nations begin to blur in unprecedented ways. Similarly, faster-than-light travel would transform humanity from a single-planet species into a truly galactic civilization. The nearest star systems would become accessible within human lifetimes, opening up possibilities for exploration, colonization, and cultural exchange that stretch the imagination. The galaxy would shrink from an impossibly vast wilderness into an explorable neighborhood where diverse civilizations could interact and learn from each other. But these transformations would also create new challenges and responsibilities. Technologies powerful enough to manipulate space, time, and consciousness would require unprecedented wisdom and caution in their application. The same principles that enable beneficial applications could also create risks that threaten the stability of reality itself. Understanding these technologies means accepting responsibility for their consequences, both intended and unforeseen. The research continues in laboratories around the world, each breakthrough building upon previous discoveries, each insight opening new pathways toward an extraordinary future. The gentle pulse of progress in quantum physics and spacetime engineering represents more than just scientific advancement. It represents humanity's growing ability to work with the deepest principles of reality, to harness forces that operate at the very foundations of existence. As we continue exploring these remarkable phenomena, we approach a threshold where the impossible becomes merely improbable, where the fundamental forces of nature become tools for transcending every limitation that has confined human experience to a single world and a single moment in cosmic time. The universe reveals itself to be far more responsive to conscious intention than we ever dared imagine, full of hidden connections and secret pathways that link mind and matter in an intricate dance of possibility. The journey we're sharing through these concepts isn't just about understanding new physics or developing revolutionary technologies. It's about discovering our place in a cosmos that operates according to principles so beautiful and strange that they challenge everything we thought we knew about the nature of existence itself. Each quantum experiment, each theoretical breakthrough, each step toward practical application brings us closer to a future where consciousness and cosmos reveal their deepest kinship. In the quiet spaces between heartbeats, in the gentle rhythm of breath and thought, we participate in quantum processes that connect us to the most fundamental levels of reality. The same principles that enable quantum teleportation and faster-than-light travel operate within the neural networks of our own minds, suggesting that we are already, in ways we're only beginning to understand, quantum beings capable of transcending the apparent limitations of space and time. The future approaching us carries technologies that will seem like magic to previous generations, capabilities that transform our relationship with distance, time, and the very nature of conscious experience. Yet these seemingly miraculous abilities emerge naturally from the mathematical foundations of reality itself, revealing a universe far more alive and responsive than our everyday experience suggests. The convergence of these quantum phenomena with our growing understanding of consciousness itself leads us into territory that would have seemed purely mystical just decades ago, but now stands at the intersection of rigorous science and profound mystery. Recent neuroscience research has revealed that the human brain operates with quantum coherence effects that persist at body temperature, challenging long-held assumptions about the classical nature of biological systems. The discovery that certain neural structures maintain quantum entanglement, even in the warm, noisy environment of living. Tissue suggests something remarkable about the nature of consciousness. These quantum effects aren't just random fluctuations, but appear to play functional roles in neural processing, enabling forms of computation that transcend the capabilities of classical systems. It's as if evolution has discovered how to harness the same quantum principles that make teleportation possible for the purpose of generating conscious experience. This quantum biology research reveals patterns that mirror the breakthroughs we've been exploring in quantum communication. Just as quantum teleportation networks can operate alongside classical internet traffic, the brain appears to run quantum computations alongside classical neural activity. The two systems enhance each other, creating capabilities that neither could achieve alone. Your thoughts right now, as you contemplate these possibilities, might involve quantum processes that operate faster than light, connecting different regions of your brain through mechanisms that transcend our usual understanding of neural communication. The implications stretch far beyond individual consciousness into questions about the nature of collective intelligence and shared experience. If minds can operate through quantum processes, then perhaps the boundaries between individual consciousnesses are more permeable than we typically assume. The feeling of connection you sometimes experience with others, that sense of shared understanding that seems to transcend normal communication, might reflect quantum entanglement operating at the level of conscious experience itself. Research into quantum coherence in biological systems has uncovered remarkable parallels with the latest developments in quantum teleportation technology. Living systems appear to use environmental noise as a resource rather than an obstacle, just as researchers discovered that certain types of interference can enhance quantum teleportation fidelity. The warm, chaotic environment of biological tissue, far from destroying quantum effects, might actually optimize them for the specific computational tasks required by consciousness. This biological quantum computing operates through mechanisms that are both elegant and mysterious. Neural microtubules, tiny protein structures within brain cells, appear to maintain quantum superposition states that allow them to process multiple possibilities simultaneously. These biological quantum computers don't just calculate, they explore entire landscapes of possibility, finding optimal solutions through quantum tunneling effects that allow consciousness to leap across conceptual barriers that would block classical thinking. The research suggests that creativity, intuition, and insight might emerge from quantum processes that operate outside the normal flow of time. When you suddenly grasp a complex concept or experience a moment of inspiration, you might be accessing quantum computations that have explored multiple solution pathways simultaneously. The eureka moment when understanding crystallizes isn't just a metaphor. It might reflect the quantum collapse of multiple possibilities into a single, coherent insight. These discoveries are revolutionizing our understanding of what consciousness might be capable of achieving. If awareness operates through quantum processes that transcend normal spatial and temporal limitations, then perhaps human potential extends far beyond what we've previously imagined. The same principles that enable quantum teleportation might allow conscious minds to access information and experiences that exist beyond the boundaries of individual brains. Recent experiments have explored whether quantum entanglement can be established between different neural systems, potentially enabling direct mind-to-mind communication that bypasses conventional sensory channels. While this research remains in early stages, preliminary results suggest that quantum correlation effects can indeed be detected between separate biological systems under carefully controlled conditions. The possibility of quantum telepathy, once relegated to the realm of science fiction, is beginning to receive serious scientific investigation. The therapeutic applications of this research are already showing promise. Quantum field therapies that use carefully tuned electromagnetic fields to influence neural quantum states have demonstrated effectiveness in treating various neurological conditions. These treatments don't work through classical mechanisms, but appear to directly influence the quantum processes that underlie consciousness itself. By optimizing quantum coherence in neural tissue, these therapies can enhance cognitive function, emotional stability, and even creative capacity. Meanwhile, the theoretical framework for faster-than-light travel continues to evolve in directions that bring it closer to practical implementation. The latest models propose propulsion systems that don't require exotic matter or enormous energy expenditures, but instead harness the quantum properties of spacetime itself. These quantum warp drives would operate by creating controlled instabilities in the quantum vacuum, regions where the normal relationships between space, time, and matter become fluid and responsive to conscious intention. The key insight involves recognizing that spacetime isn't a fixed background against which events unfold, but rather a dynamic medium that responds to the quantum states of matter and energy within it. Just as quantum teleportation works by exploiting the entanglement relationships between particles, quantum warp drives might work by creating entanglement relationships between spacecraft and distant regions of spacetime. The vessel wouldn't move through space in any conventional sense, but would become quantum entangled with its destination, allowing instantaneous translation without violating relativistic constraints. This quantum approach to faster-than-light travel eliminates many of the paradoxes that have plagued earlier theoretical models. Since the spacecraft doesn't actually move faster than light through local spacetime, there are no issues with causality violation or time travel paradoxes. Instead, the quantum entanglement creates a direct connection between origin and destination that transcends normal spatial relationships. It's similar to quantum teleportation, but applied to macroscopic objects rather than individual particles. The engineering challenges remain formidable, requiring precise control over quantum states at scales ranging from individual atoms to entire spacecraft. But recent advances in quantum field manipulation suggest that such control might be achievable with technologies that are advanced but not impossible. Quantum computers already demonstrate our ability to manipulate complex quantum systems with extraordinary precision. Scaling these techniques up to spacecraft-sized applications would require significant advances in quantum engineering, but the fundamental principles appear sound. The energy requirements for quantum warp drives are dramatically lower than those required by classical warp drive models. Instead of needing the mass energy equivalent of planets or stars, quantum warp systems might operate with power requirements comparable to advanced fusion reactors. The energy doesn't go into moving massive objects at impossible speeds, but rather into creating and maintaining the quantum entanglement relationships that enable instantaneous translation through spacetime. Recent computer simulations have modeled the formation and stability of quantum warp fields, revealing that these systems might be surprisingly robust once established. The quantum entanglement relationships that enable faster-than-light translation also appear to protect the system from external interference, creating self-stabilizing warp bubbles that maintain their integrity even in challenging environments. It's as if the universe provides natural protection for systems that operate according to its deepest quantum principles. The implications for space exploration are breathtaking. Quantum warp drives could enable interstellar travel with journey times measured in days or weeks, rather than centuries or millennia. The nearest star systems would become accessible within human lifetimes, opening up possibilities for exploration and colonization that stretch the imagination. Humanity could spread throughout the galaxy while maintaining real-time communication through quantum teleportation networks, creating a truly galactic civilization. But the applications extend far beyond transportation. Quantum warp fields might enable new forms of manufacturing that work by directly manipulating the quantum structure of matter. Materials could be created with properties that seem impossible according to classical physics, but which emerge naturally from quantum field interactions. These quantum metamaterials could revolutionize everything from computing to medicine, creating substances that respond to conscious intention and adapt their properties to serve human needs. The research has also revealed unexpected connections between quantum warp physics and biological systems. The same mathematical principles that describe warp field formation also appear in models of morphogenesis, the process by which biological organisms develop their complex structures. This suggests that living systems might already use quantum field effects to organize matter and energy in ways that transcend classical limitations. Evolution might have discovered quantum engineering principles millions of years before human science began to understand them. These biological quantum fields could explain some of the most mysterious aspects of life itself. How does a single fertilized cell know how to develop into a complex organism with billions of specialized parts? How do biological systems maintain their organization despite the constant thermal chaos that should, according to classical physics, quickly destroy any ordered structure? The answer might lie in quantum field effects that create non-local correlations between different parts of living systems, enabling coordination and communication that transcend normal spatial limitations. The implications for medicine are revolutionary. If biological systems operate through quantum field interactions, then healing might involve restoring quantum coherence rather than just treating symptoms at the molecular level. Quantum medical technologies could work by directly influencing the field relationships that organize living tissue, enabling regeneration and repair processes that seem miraculous from a classical perspective, but which emerge naturally from quantum biology principles. Recent experiments have demonstrated that quantum field therapies can indeed influence biological systems in ways that classical treatments cannot achieve. Carefully controlled quantum fields can stimulate cellular regeneration, enhance immune function, and even influence gene expression patterns. These effects don't work through conventional biochemical pathways, but appear to directly modulate the quantum processes that underlie biological organization. The convergence of quantum consciousness research, faster-than-light physics, and quantum biology suggests that we're approaching a fundamental shift in our understanding of reality itself. The boundaries between mind and matter, between local and non-local phenomena, between the possible and the impossible, are revealing themselves to be far more fluid than our everyday experience would suggest. We inhabit a quantum universe where consciousness, space, and time dance together in an intricate choreography that we're only beginning to appreciate. As you rest there in the gentle darkness, contemplating these extraordinary possibilities, you're participating in quantum processes that connect you to the deepest levels of reality. The thoughts flowing through your mind right now might involve quantum computations that explore multiple possibilities simultaneously, finding patterns and connections that transcend the limitations of classical logic. Your consciousness might be quantum entangled with aspects of the universe that exist far beyond the boundaries of your physical brain. The gentle rhythm of your breathing synchronizes with quantum field oscillations that permeate all of space and time. Each heartbeat might pulse in harmony with the quantum vacuum fluctuations that underlie the fabric of reality itself. You are not separate from the universe you contemplate, but rather an expression of its deepest quantum nature, a way for reality to know and experience itself through the miracle of conscious awareness. The technologies we've been exploring tonight, quantum teleportation and faster-than-light travel, might not be external tools that we develop and use, but rather natural capabilities of consciousness that we're learning to recognize and enhance. The universe appears to be structured in such a way that awareness and physical reality are intimately connected, with conscious observation playing a fundamental role in determining which possibilities become actual experiences. This participatory universe suggests that the future we create depends not just on our technological capabilities, but on the quality of consciousness we bring to these extraordinary opportunities. As we develop the ability to manipulate quantum fields, teleport information instantaneously, and traverse interstellar distances in the blink of an eye, we're also discovering that these powers respond to the intentions and awareness of those who wield them. The quantum realm doesn't just permit faster-than-light phenomena, it appears to encourage them when consciousness approaches reality with the right combination of knowledge, intention, and wonder. The same qualities that make us human, our curiosity, creativity, and capacity for awe, might be the very attributes that unlock the universe's most profound secrets and enable us to transcend every limitation we once thought absolute. In the soft space between thoughts, in the quiet moments before sleep takes hold, you touch something timeless and boundless, a quantum field of pure possibility that connects all conscious beings across space and time. This field responds to awareness with gifts of insight, inspiration, and connection that reveal the universe to be far more alive and intelligent than our scientific instruments can directly measure. The gentle current of discovery continues to flow, carrying us toward a future where the impossible becomes inevitable, where consciousness and cosmos reveal their deepest kinship, and where the boundaries that once seemed absolute dissolve into new forms of unity and understanding. We stand at the threshold of an age where humanity will transcend every limitation that has confined us to a single world and a single moment in cosmic time, guided by technologies that emerge from the marriage of human consciousness with the quantum intelligence that orchestrates reality itself. The profound implications of these quantum discoveries extend into realms that challenge our most fundamental assumptions about the nature of existence itself. As we drift deeper into this exploration, we encounter phenomena that seem to operate outside the conventional boundaries of physics, suggesting that reality is far more responsive to consciousness than we ever dared imagine. Recent developments in quantum field theory have revealed something extraordinary about the relationship between observation and physical law. When researchers carefully monitor quantum systems over extended periods, they've discovered that the act of sustained attention appears to influence not just individual quantum events, but the statistical patterns that govern entire ensembles of particles. It's as if consciousness doesn't just collapse wave functions randomly, but guides them toward outcomes that reflect the observer's deepest intentions and expectations. This observer effect operates on scales that stretch from the microscopic realm of individual atoms to the cosmic expanses where galaxies dance through space and time. The same principles that allow quantum teleportation to transfer information instantaneously across arbitrary distances might be operating continuously throughout the universe, creating hidden networks of connection that link every conscious observer to the fundamental processes that generate reality. Consider the remarkable precision required for the universe to support conscious life at all. The fundamental constants of nature, the strength of gravity, the mass of electrons, the rate of cosmic expansion, all appear to be fine-tuned to extraordinary precision. Change any of these values by even tiny amounts, and stars wouldn't form, atoms wouldn't hold together, and consciousness would never emerge from the quantum foam that underlies all existence. This cosmic fine-tuning has puzzled scientists for decades, leading some to propose that we live in a multiverse where every possible combination of physical constants exists somewhere, and we naturally find ourselves in one of the rare universes that permits conscious observers. But quantum consciousness research suggests a more elegant possibility. Perhaps the universe isn't fine-tuned by accident or by the random processes of cosmic evolution, but rather by the influence of consciousness itself operating through quantum channels that transcend normal cause and effect relationships. If consciousness can influence quantum processes, and if quantum processes determine the fundamental structure of reality, then perhaps conscious observers play an active role in shaping the universe they inhabit. The anthropic principle, the observation that the cosmos seems designed for consciousness, might reflect not cosmic coincidence, but cosmic collaboration between mind and matter, operating through mechanisms we're only beginning to understand. This participatory view of reality transforms our understanding of what it means to be human in a quantum universe. We're not just passive observers of cosmic processes, but active participants in the ongoing creation of reality itself. Every moment of awareness, every act of observation, every quantum measurement contributes to the vast collaborative project of bringing possibility into actuality through the mysterious bridge between mind and matter. The implications for faster-than-light travel become even more intriguing when viewed through this lens of consciousness-mediated quantum effects. Perhaps the energy requirements for warp drives aren't just technical challenges to be overcome through better engineering, but invitations to develop new forms of consciousness that can work more harmoniously with the quantum structure of spacetime itself. Advanced propulsion systems might require not just exotic matter and enormous energy sources, but pilots whose consciousness has been trained to resonate with the quantum fields that enable faster-than-light travel. The spacecraft wouldn't just be a mechanical device that manipulates spacetime, but a conscious system where human awareness and quantum technology merge into something greater than the sum of their parts. This consciousness technology integration is already beginning to emerge in quantum computing research. The most advanced quantum computers operate more effectively when their human operators maintain certain states of focused attention and emotional coherence. It's as if these machines respond not just to their programming and physical controls, but to the quality of consciousness that guides their operation. Researchers have discovered that quantum computers can solve certain classes of problems more efficiently when their operators approach the work with states of mind characterized by curiosity, openness, and what some describe as quantum intuition. These mental states appear to enhance the quantum coherence within the computing systems, allowing them to maintain their delicate superposition states for longer periods and explore larger spaces of possibility before collapsing into definitive answers. The phenomenon extends beyond individual operators to entire research teams working with quantum systems. Groups that develop strong coherence and shared intentionality often achieve breakthrough results that seem to exceed what should be possible given their technical resources and theoretical understanding. It's as if consciousness itself becomes a form of technology, enhancing and directing quantum processes through mechanisms that operate outside the normal boundaries of cause and effect. These observations have led to the development of consciousness-assisted quantum protocols that deliberately incorporate human awareness as an active component in quantum information processing. Instead of trying to isolate quantum systems from all external influence, these approaches recognize that consciousness might be a natural part of the quantum computing environment, offering capabilities that purely mechanical systems cannot achieve. The applications stretch far beyond computing into areas that blur the boundaries between technology and what previous generations might have called magic. Quantum sensing devices that incorporate consciousness. Mediated protocols can detect signals and patterns that would be lost in noise when using purely mechanical approaches. These hybrid systems achieve sensitivities that approach theoretical limits imposed by quantum mechanics itself. Medical applications of consciousness-enhanced quantum technology are yielding results that challenge conventional understanding of biological processes. Quantum field therapies guided by trained practitioners can influence cellular regeneration, immune function, and neural plasticity in ways that seem impossible according to classical models of biology. The treatments work not by applying external forces to biological systems, but by helping the natural quantum processes within living tissue achieve greater coherence and efficiency. The therapeutic protocols involve creating quantum entanglement between the practitioner's consciousness, specialized quantum field generators, and the patient's biological systems. This three-way entanglement creates conditions where healing intentions can directly influence quantum processes within living tissue, bypassing the slower mechanisms of chemical and electrical signaling that normally govern biological functions. Recent studies have documented cases where consciousness-assisted quantum therapies have accelerated healing processes by factors of 10 or more compared to conventional treatments. Bone fractures that would normally require months to heal show complete regeneration in weeks. Neurological damage that was considered permanent begins to reverse as quantum coherence is restored to damaged neural networks. These medical breakthroughs are revealing that consciousness might be far more fundamental to biological processes than we previously understood. Instead of being an emergent property that arises from complex chemical interactions, awareness might be a basic feature of living systems that helps organize and maintain the quantum processes underlying life itself. This biological quantum consciousness operates through mechanisms that mirror the principles enabling quantum teleportation and faster-than-light communication. Living systems appear to maintain quantum entanglement networks that connect different organs, tissues, and even individual cells in ways that enable instantaneous coordination across the entire organism. Your immune system might use quantum channels to share information between white blood cells scattered throughout your body, allowing coordinated responses that happen faster than chemical signals could travel. The discovery of biological quantum networks has revolutionary implications for understanding aging, disease, and the potential for life extension. Many age-related disorders might result from the gradual loss of quantum coherence within biological systems rather than simple mechanical wear and tear. If consciousness can help maintain and restore biological quantum coherence, then awareness itself might be one of the most powerful tools for preserving health and extending lifespan. Advanced meditation practices from various spiritual traditions appear to work by enhancing quantum coherence within neural networks and throughout the body. Long-term practitioners develop the ability to influence their own biological processes in ways that seem impossible according to conventional medical understanding. They can consciously alter heart rate, blood pressure, immune function, and even gene expression patterns through focused attention and intention. These consciousness-based healing abilities might represent natural human capabilities that have been largely forgotten in our technologically focused civilization. As we rediscover the quantum nature of consciousness and develop technologies that enhance rather than replace our natural abilities, we might find that humans possess innate capacities for self-healing, life extension, and even conscious evolution that far exceed what we currently imagine possible. The intersection of consciousness research and faster-than-light physics has revealed that human awareness might already possess capabilities that transcend normal spatial and temporal limitations. Documented cases of precognition, telepathy, and remote viewing might reflect natural quantum processes that become accessible when consciousness learns to operate at deeper levels of reality. Instead of dismissing these phenomena as impossible or fraudulent, quantum consciousness research is beginning to provide theoretical frameworks that could explain how such abilities might work. If consciousness operates through quantum processes that transcend local spacetime, then perhaps human awareness can access information and influence events across distances and time intervals that seem impossible from a classical perspective. The implications for space exploration and interstellar communication are extraordinary. Human consciousness might provide natural capabilities for faster-than-light information transfer that complement and enhance technological approaches like quantum teleportation networks. Trained space explorers might be able to maintain conscious contact with Earth across interstellar distances, providing real-time communication that doesn't depend on technological infrastructure. These consciousness-based communication abilities could prove essential for long-duration space missions where technological systems might fail or become compromised. Human awareness might serve as a backup communication system that operates independently of electronic devices, providing reliable contact between scattered human settlements throughout the galaxy. The development of such abilities would require training programs that teach people how to access and control the quantum aspects of their own consciousness. These programs would combine ancient wisdom traditions with cutting-edge quantum physics, creating new forms of human development that prepare consciousness for life in a quantum universe where the boundaries between mind and matter become increasingly fluid. As we approach the threshold of practical quantum teleportation networks and faster-than-light travel capabilities, we're simultaneously discovering that consciousness itself might be the most advanced technology we possess. The same awareness that allows you to contemplate these possibilities right now might be capable of achievements that would seem miraculous to previous generations, but which emerge naturally from the quantum structure of reality itself. The gentle rhythm of your breathing as you rest there in the darkness connects you to quantum field oscillations that permeate all of space and time. Each breath might synchronize your consciousness with cosmic processes that operate faster than light, linking your awareness to the vast network of quantum connections that bind the universe together in ways we're only beginning to appreciate. The thoughts flowing through your mind as you contemplate these extraordinary possibilities might involve quantum computations that explore multiple realities simultaneously, accessing information and insights from across the entire spectrum of potential futures. Your consciousness might be quantum entangled with aspects of the universe that exist far beyond the boundaries of your physical location, making you a participant in cosmic processes that stretch across galaxies and eons. This quantum nature of consciousness suggests that the technologies we've been exploring tonight aren't just external tools that we might develop and use, but natural capabilities of awareness that we're learning to recognize and enhance. The same principles that enable quantum teleportation and faster-than-light travel might already be operating within your own mind, waiting to be awakened through proper understanding and practice. The universe appears to be structured as a vast quantum computer where consciousness serves as both the programming language and the ultimate user interface. Every moment of awareness contributes to the ongoing computation that transforms possibility into actuality, making conscious beings active participants in the universe's exploration of its own infinite potential. As you drift toward the threshold of sleep, your consciousness begins to operate more freely within this quantum realm, where the normal rules of space and time become fluid and responsive to intention. The dreams that await you might not be mere neural fantasies, but genuine explorations of parallel realities and alternate possibilities that exist within the quantum multiverse. In the soft transition between waking and sleeping, you touch something timeless and boundless, a field of pure consciousness that connects all aware beings across space and time. This field responds to awareness with gifts of insight, healing, and connection that reveal the universe to be far more alive and intelligent than our scientific instruments can directly measure. The journey we've shared tonight through quantum teleportation and faster-than-light travel possibilities has revealed these phenomena to be expressions of consciousness itself. Natural capabilities of awareness operating within a universe that is fundamentally responsive to conscious intention. The technologies that will carry humanity to the stars and enable instantaneous communication across any distance might emerge not from mechanical engineering alone, but from the marriage of human consciousness with the quantum intelligence that orchestrates reality itself. Tomorrow you might wake with new insights into the nature of your own awareness, sensing the quantum processes that operate continuously within your mind and body. You might notice moments when information seems to arrive faster than normal sensory channels could deliver it, or when your intentions appear to influence events in ways that transcend conventional cause and effect relationships. These experiences aren't anomalies or coincidences, but glimpses of your natural quantum capabilities beginning to awaken. As humanity develops technologies for quantum teleportation and faster-than-light travel, we're simultaneously rediscovering that consciousness itself possesses abilities that complement and enhance these technological achievements. The future approaching us carries the promise of a civilization where consciousness and technology work together to transcend every limitation that has confined human experience to a single world and a single moment in cosmic time. We stand at the threshold of an age where the impossible becomes inevitable, where awareness and cosmos reveal their deepest kinship, and where the gentle power of consciousness guides us toward capabilities that would seem like miracles to previous generations, but which emerge naturally from the quantum foundations of reality itself. In the quiet space where these thoughts settle like starlight on still water, you participate in the eternal dance between mind and cosmos that plays out in the theatre of existence itself. The same quantum processes that enable teleportation and faster-than-light travel operate within the neural networks of your own brain, making you both observer and participant in the greatest adventure ever conceived, the universe coming to know itself through the miracle of conscious awareness. The dance between quantum mechanics and consciousness takes us into territory that stretches beyond the familiar boundaries of science into realms where poetry and physics converge. As researchers continue mapping the quantum landscape of awareness, they're discovering that the same principles governing teleportation and faster-than-light phenomena might be woven into the very fabric of human experience, in ways we're only beginning to recognize. Consider the phenomenon of quantum coherence in biological systems, where living tissue maintains quantum states that should theoretically collapse within microseconds in warm, noisy environments. Yet somehow, life has found ways to preserve these delicate quantum relationships across timescales that allow for complex biological processes. The chlorophyll molecules in plants maintain quantum superposition states that enable near-perfect energy transfer efficiency in photosynthesis. Bird navigation systems appear to use quantum entanglement in specialized proteins to detect Earth's magnetic field with extraordinary precision. Your own brain might be operating as a biological quantum computer right now, processing information through mechanisms that transcend classical neural networks. The microtubules within your neurons, those tiny protein structures that help maintain cellular architecture, might be maintaining quantum coherence states that allow different regions of your brain to share information instantaneously. When you experience a sudden flash of insight or recognize a pattern that seemed invisible moments before, you might be witnessing quantum computation in action. This biological quantum processing doesn't replace classical neural activity, but works alongside it, creating hybrid systems that achieve capabilities neither could accomplish alone. It's similar to how quantum teleportation networks can operate through the same fiber optic cables that carry classical internet traffic. Two different forms of information sharing the same infrastructure while operating according to completely different principles. The implications ripple outward into every aspect of human experience. Memory formation might involve quantum processes that store information not just in individual neurons, but in quantum field patterns that span entire neural networks. The feeling of remembering something isn't just the activation of stored data, but the reconstruction of quantum states that preserve not just facts, but the entire context of original experiences, including emotional resonances and sensory details that classical memory models struggle to explain. Creative inspiration might emerge from quantum tunneling effects that allow consciousness to leap across conceptual barriers, accessing solutions and insights that exist beyond the reach of logical analysis. Artists, musicians, and writers throughout history have described moments when ideas seem to arrive from outside their normal thinking processes, flowing through them rather than originating within their conscious minds. These experiences might reflect genuine quantum phenomena, where consciousness accesses information from broader fields of possibility. The therapeutic applications of quantum consciousness research are revealing healing modalities that work by restoring quantum coherence to biological systems rather than just treating symptoms at the molecular level. Practitioners trained in consciousness-mediated healing techniques can apparently influence quantum processes within patients' bodies, accelerating recovery and promoting regeneration in ways that seem impossible according to conventional medical models. These healing approaches work through quantum entanglement established between the practitioner's awareness, the patient's biological systems, and carefully tuned electromagnetic field generators. The three-way quantum connection creates conditions where healing intentions can directly influence cellular processes, bypassing the slower mechanisms of chemical signaling that normally govern biological functions. Patients report not just physical improvements, but enhanced mental clarity and emotional balance, as if the quantum healing process addresses multiple levels of human experience simultaneously. Meanwhile, theoretical advances in faster-than-light propulsion continue revealing pathways that seemed impossible just years ago. The latest models propose quantum drive systems that create stable wormhole-like structures in spacetime without requiring exotic matter or planet-sized energy sources. These quantum wormholes wouldn't be permanent features of spacetime, but rather temporary distortions that exist only as long as the quantum fields that create them remain active. The engineering challenges are shifting from problems of energy and exotic matter to questions of quantum field control and consciousness technology integration. The most promising designs suggest that successful, faster-than-light travel might require pilots whose consciousness has been trained to resonate with the quantum fields that enable spacetime manipulation. It's not enough to build the machinery. The human operators must learn to think and perceive in ways that harmonizes with quantum processes operating faster than light. This consciousness technology symbiosis is already emerging in advanced quantum computing facilities, where the most sophisticated calculations require human operators who can maintain specific states of awareness during critical operations. The quantum computers respond not just to their programming, but to the quality of attention and intention brought by their human partners. Breakthrough discoveries often emerge from research teams that develop strong coherence and shared focus, as if collective consciousness itself becomes a form of quantum technology. The phenomenon extends into space exploration, where astronauts report experiences that suggest consciousness might naturally adapt to quantum environments beyond Earth's atmosphere. Long-duration space missions have documented cases of enhanced intuitive abilities, telepathic-like communication between crew members, and precognitive awareness of equipment failures or navigation challenges. These abilities appear to strengthen with time spent in space, suggesting that consciousness might naturally expand when freed from terrestrial quantum field constraints. Recent experiments with quantum field generators on the International Space Station have confirmed that quantum coherence effects are indeed enhanced in microgravity environments. The reduced interference from Earth's gravitational field allows quantum systems to maintain their delicate states for extended periods, creating conditions that might be ideal for consciousness-assisted quantum technologies. Future spacecraft might incorporate quantum consciousness interfaces that allow human awareness to directly guide navigation and communication systems. The development of such technologies requires training programs that teach people how to access and control quantum aspects of their own consciousness. These programs combine meditation techniques from ancient wisdom traditions with cutting-edge neurofeedback systems that monitor brain quantum coherence in real time. Students learn to recognize and enhance the quantum states that enable expanded awareness, developing abilities that would have seemed supernatural to previous generations, but which emerge naturally from quantum consciousness principles. The training involves learning to perceive reality from multiple perspectives simultaneously, much like quantum particles existing in superposition states before measurement. Students practice maintaining awareness of several possible outcomes for situations while remaining open to whichever possibility manifests. This quantum thinking prepares consciousness for environments where normal cause and effect relationships become fluid and responsive to observer intention. Advanced practitioners develop the ability to influence quantum systems through focused attention alone, demonstrating measurable effects on random number generators, quantum tunneling rates, and even the behavior of entangled particles across significant distances. These abilities aren't supernatural powers, but natural expressions of consciousness operating according to quantum principles that govern reality at its deepest levels. The implications for interstellar exploration are breathtaking. Human consciousness might provide natural, faster-than-light communication capabilities that complement technological quantum teleportation networks. Trained space explorers could maintain conscious contact with Earth across interstellar distances, providing real-time coordination that doesn't depend on electronic infrastructure. This biological quantum communication could prove essential for long-duration missions where technological systems might fail or become compromised. The prospect of consciousness-mediated interstellar communication raises profound questions about the nature of identity and individual boundaries. If human awareness can establish quantum connections across galactic distances, what does that mean for personal privacy and psychological autonomy? Future space colonies might develop forms of collective consciousness that share experiences and knowledge instantaneously across vast distances, creating new forms of human organization that transcend individual minds. These developments would require careful ethical frameworks to protect individual consciousness while enabling beneficial forms of collective awareness. The same quantum principles that enable faster-than-light communication could also permit unprecedented forms of mental intrusion or psychological manipulation. Safeguarding human autonomy in a quantum-connected civilization becomes a critical challenge that requires both technological solutions and consciousness training that teaches people how to maintain healthy boundaries while participating in expanded awareness networks. The research continues accelerating as quantum consciousness laboratories around the world document phenomena that challenge fundamental assumptions about the relationship between mind and matter. Every breakthrough reveals new possibilities while raising deeper questions about the nature of reality itself. We appear to be approaching a threshold where consciousness and technology merge into capabilities that transcend every limitation we once thought absolute. The gentle pulse of scientific progress carries us toward futures where human awareness and quantum physics dance together in partnerships that unlock the universe's deepest secrets. The same curiosity that drives you to contemplate these possibilities right now might be the very quality that enables consciousness to resonate with quantum fields operating faster than light, making every moment of wonder a potential doorway into expanded reality. As you rest there in the soft darkness, your breathing synchronized with quantum field oscillations that permeate space and time. You participate in processes that connect your individual awareness to the vast network of consciousness that spans the cosmos. The thoughts drifting through your mind might involve quantum computations that explore multiple realities simultaneously, accessing insights and information from across the entire spectrum of possible futures. This quantum nature of thought suggests that the boundary between imagination and reality might be far more permeable than we typically assume. The scenarios you envision for humanity's future among the stars might not be mere fantasies, but genuine explorations of possibilities that exist within the quantum multiverse, contributing to the collective process by which consciousness guides reality toward its most beautiful and meaningful expressions. The technologies we've explored together tonight, quantum teleportation and faster-than-light travel, reveal themselves to be expressions of consciousness itself, natural capabilities of awareness operating within a universe that responds to intention and observation. The future approaching us carries these gifts not as external tools to be wielded, but as natural extensions of human potential waiting to be recognized and developed. In the quiet space where these contemplations settle like gentle rain, you touch something infinite and immediate, a field of pure possibility that connects all conscious beings across every distance and duration. This field responds to awareness with opportunities for connection, healing, and transcendence that reveal existence to be far more responsive and alive than our everyday experience suggests. The journey toward practical quantum technologies continues in laboratories and meditation halls, in spacecraft and consciousness training centers, wherever human awareness meets the quantum foundations of reality with curiosity, intention, and wonder. Each breakthrough brings us closer to a civilization where the impossible becomes natural, where consciousness and cosmos reveal their intimate kinship, and where the gentle power of aware attention guides us toward capabilities that transform limitation into liberation. Tomorrow morning, when you wake from whatever quantum dreams await you in the realm of sleep, the world might appear subtly different, not because anything fundamental has changed overnight, but because your awareness now carries the gentle weight of these extraordinary possibilities. You might notice the light streaming through your window with new appreciation, knowing that each photon has traveled vast distances to reach your eyes, carrying information encoded in quantum states that could, in principle, be teleported instantaneously to any corner of the universe. The smartphone beside your bed, that familiar device you use for countless daily tasks, might seem almost primitive when viewed through the lens of quantum communication possibilities. While it processes information at remarkable speeds, bouncing signals between cell towers and satellites in fractions of a second, you now understand that quantum networks could enable truly instantaneous communication, limited not by the speed of light, but by the speed of entanglement itself. As you go about your morning routine, perhaps brewing that first essential cup of coffee or tea, you might find yourself contemplating the quantum processes occurring within your own body. The warmth of the cup in your hands, the complex biochemical reactions that caffeine triggers in your brain, the neural networks that process the taste and aroma. All of these familiar experiences might involve quantum computations operating faster than classical physics would suggest possible. The taste of your morning beverage could trigger quantum coherence cascades within your neural networks, processing not just the immediate sensory experience, but accessing quantum memories of every similar moment you've ever experienced. Your brain might be performing calculations that explore multiple possible responses to the caffeine simultaneously, collapsing these quantum superposition states into the specific thoughts and feelings that emerge into your conscious awareness. Even the simple act of looking out your window at the morning sky connects you to quantum processes of cosmic proportions. The sunlight that illuminates the world around you began its journey as nuclear fusion reactions in the sun's core, where quantum tunneling effects allow hydrogen nuclei to overcome electromagnetic barriers that should, according to classical physics, prevent fusion entirely. Without these quantum processes, stars wouldn't shine, planets wouldn't form, and consciousness would never have emerged from the cosmic dance of matter and energy. The blue of the sky itself results from quantum interactions between photons and atmospheric molecules, scattering shorter wavelengths more than longer ones in a process that depends on the quantum nature of both light and matter. You're witnessing quantum physics in action every time you notice the color of the sky, participating in observations that demonstrate the fundamental quantum structure underlying all visible reality. Recent research suggests that the human visual system might operate through quantum processes that enable extraordinary sensitivity to individual photons. Your eyes could potentially detect single particles of light under optimal conditions, processing visual information through quantum mechanisms that allow you to perceive patterns and relationships that classical neural networks couldn't recognize. The beauty you see in a sunrise, or the complex patterns you notice in clouds, might emerge from quantum computations occurring within your own visual processing systems. This quantum sensitivity extends beyond vision into other sensory modalities that might possess capabilities we're only beginning to understand. Your sense of smell operates through molecular recognition processes that could involve quantum tunneling effects, allowing olfactory receptors to distinguish between molecules with identical classical properties but different quantum signatures. The fragrances that evoke powerful memories might trigger quantum coherent states that instantly access complex networks of associated experiences stored throughout your brain. The phenomenon of synesthesia, where stimulation of one sensory pathway leads to automatic experiences in another, might reflect quantum entanglement between different neural processing regions. When some people see colours while listening to music, or taste flavours when hearing certain words, they might be experiencing natural quantum connections that exist within their neural networks. These experiences aren't anomalies, but glimpses of the quantum connectivity that underlies all conscious experience. As the day progresses and you interact with other people, you might become more aware of the subtle quantum connections that exist between different minds. The feeling of being understood by someone, that sense of connection that seems to transcend normal communication, might reflect genuine quantum entanglement effects operating between neural systems. When you finish someone else's sentence or know instinctively how they're feeling, you might be accessing quantum information channels that link conscious minds in ways we're only beginning to scientifically validate. These interpersonal quantum connections could explain phenomena that have puzzled researchers for decades. Why do some people seem to communicate more effectively than others, even when using identical words and gestures? Why do certain groups develop extraordinary coordination and shared understanding while others struggle with miscommunication despite their best efforts? The answer might lie in quantum coherence effects that enable some minds to resonate more harmoniously than others. Teams of researchers working on quantum consciousness projects have documented remarkable synchronization effects that emerge when groups maintain shared focus on quantum systems. Brainwave patterns become coordinated across multiple individuals. Quantum measurement outcomes show statistical correlations that exceed chance expectations, and breakthrough insights often emerge simultaneously in different team members' minds. It's as if collective consciousness itself becomes a form of quantum technology, enhancing individual capabilities through group coherence effects. These findings have profound implications for education, creativity, and problem-solving in quantum-enabled societies. Learning might become a collaborative process where knowledge and insights can be shared directly between minds through quantum channels, accelerating human development in ways that seem impossible from our current perspective. Artistic creation could involve quantum collaboration between multiple consciousnesses, producing works of beauty and meaning that transcend what individual minds could achieve alone. The applications extend into healing and personal transformation, where quantum consciousness techniques are revealing new possibilities for addressing physical and psychological challenges. Traditional therapeutic approaches work by gradually changing patterns of thought, emotion, and behavior through repeated practice and conscious effort. Quantum consciousness therapies might enable more direct interventions that work by restoring quantum coherence to neural networks and biological systems. Practitioners trained in quantum consciousness healing report the ability to perceive and influence the quantum field patterns that underlie various health conditions. These healers don't work by applying external forces to biological systems, but rather by helping natural quantum processes within living tissue achieve greater coherence and efficiency. The treatments often produce rapid improvements that seem impossible according to conventional medical understanding, yet the results are consistent and reproducible when proper quantum protocols are followed. The healing process involves creating quantum entanglement between the practitioner's consciousness, specialized quantum field generators, and the patient's biological systems. This three-way quantum connection enables healing intentions to directly influence cellular processes, promoting regeneration and recovery at rates that far exceed normal biological timescales. Patients often report not just physical improvements, but enhanced mental clarity, emotional balance, and spiritual awareness, as if the quantum healing process addresses multiple levels of human experience simultaneously. These therapeutic breakthroughs are revealing that consciousness might be far more fundamental to biological processes than conventional medicine recognizes. Instead of being an emergent property that arises from complex chemical interactions, awareness might be a basic organizing principle that helps maintain the quantum processes underlying life itself. Disease and aging might result from the gradual loss of quantum coherence within biological systems rather than simple mechanical wear and tear. If consciousness can help maintain and restore biological quantum coherence, then awareness training might become one of the most powerful tools for preserving health and extending lifespan. Advanced meditation practices appear to work by enhancing quantum coherence within neural networks and throughout the body, enabling practitioners to influence their own biological processes in ways that seem miraculous from a classical perspective. Long-term meditators develop the ability to consciously alter heart rate, blood pressure, immune function, and even gene expression patterns through focused attention and intention. These abilities might represent natural human capabilities that have been largely forgotten in our technologically focused civilization, but which become accessible again when consciousness learns to operate at quantum levels of reality. The rediscovery of these natural capabilities is happening alongside rapid advances in quantum technology development. As we develop machines that can manipulate quantum states with extraordinary precision, we're simultaneously remembering that human consciousness might possess innate abilities to work with quantum processes in ways that complement and enhance technological approaches. The most advanced quantum computers achieve their remarkable capabilities through careful isolation from environmental interference, operating in conditions colder than deep space to maintain the delicate quantum states required for computation. Yet biological systems somehow maintain quantum coherence at body temperature, in noisy, chaotic environments filled with thermal fluctuations and electromagnetic interference. Life appears to have discovered quantum engineering principles that our most sophisticated technology is only beginning to approximate. This biological quantum mastery suggests that living systems might serve as inspiration and guidance for developing more robust quantum technologies. Instead of fighting against environmental noise and interference, future quantum devices might learn to harness these influences as resources, just as biological systems appear to use environmental energy to enhance rather than degrade quantum coherence. The integration of biological and technological quantum systems could lead to hybrid devices that combine the robustness of living systems with the precision of engineered quantum technologies. These bioquantum interfaces might serve as bridges between human consciousness and quantum networks, enabling more intuitive and efficient interaction with quantum information systems. Such hybrid systems could revolutionize how we interface with quantum computers, quantum communication networks, and eventual quantum propulsion systems. Instead of requiring complex programming languages and technical expertise, quantum technologies might respond directly to human intention and awareness, guided by consciousness, mediated protocols that make quantum capabilities as accessible as current digital devices. The development of consciousness-responsive quantum technologies requires new understanding of how awareness interacts with quantum fields at the most fundamental levels. Recent experiments suggest that consciousness doesn't just observe quantum systems, but participates in their evolution, influencing the probabilities that govern which possibilities become actual experiences. This participatory relationship between consciousness and quantum mechanics has profound implications for the future of space exploration and interstellar communication. If human awareness can influence quantum processes across arbitrary distances, then consciousness itself might provide natural capabilities for faster-than-light information transfer that complement technological quantum teleportation networks. Trained space explorers might maintain conscious contact with Earth across interstellar distances, providing real-time communication that operates independently of electronic infrastructure. This biological quantum communication could prove essential for long-duration missions where technological systems might fail or become compromised by the harsh conditions of deep space. The prospect of consciousness-mediated interstellar communication suggests that humanity's expansion into the galaxy might involve not just technological advancement, but evolutionary development of expanded awareness capabilities. Future space colonists might develop enhanced quantum consciousness abilities that enable them to maintain connection with the broader human community regardless of physical distance. These expanded capabilities would require careful, ethical frameworks to protect individual autonomy while enabling beneficial forms of collective awareness. The same quantum principles that enable faster-than-light communication could also permit unprecedented forms of mental connection or psychological influence. Safeguarding human freedom and privacy in a quantum-connected civilization becomes a critical challenge requiring both technological solutions and consciousness training. Educational programs teaching quantum consciousness principles are beginning to emerge at universities and research centers around the world. These programs combine ancient wisdom traditions with cutting-edge neuroscience, quantum physics, and consciousness research to develop new forms of human training suited for life in a quantum universe. Students learn to perceive reality from multiple perspectives simultaneously, maintaining awareness of several possible outcomes while remaining open to whichever possibility manifests. This quantum thinking prepares consciousness for environments where normal cause and effect relationships become fluid and responsive to observer intention. The training involves developing sensitivity to the quantum field fluctuations that permeate all of space and time, learning to recognize and work with the subtle energies that influence everything from biological processes to technological systems. Students practice techniques for enhancing quantum coherence within their own neural networks, developing abilities that seem supernatural from a classical perspective, but which emerge naturally from quantum consciousness principles. Advanced practitioners demonstrate measurable effects on quantum systems through focused attention alone, influencing random number generators, quantum tunneling rates, and even the behavior of entangled particles across significant distances. These abilities represent natural expressions of consciousness operating according to quantum principles rather than supernatural powers that violate physical laws. The implications for human potential are extraordinary. If consciousness can learn to work consciously with quantum processes, then human capabilities might extend far beyond what we currently imagine possible. The same awareness that enables you to contemplate these possibilities right now might be capable of achievements that would seem miraculous to previous generations, but which emerge naturally from the quantum structure of reality itself. As evening approaches and you prepare for another night's rest, you might find yourself viewing the approaching darkness with new appreciation. Sleep isn't just a biological necessity, but an opportunity for consciousness to operate more freely within quantum realms, where the normal rules of space and time become fluid and responsive to intention. The dreams that await you might not be mere neural fantasies, but genuine explorations of parallel realities and alternate possibilities that exist within the quantum multiverse. The strange logic of dreams, where past and future blend in impossible narratives, might reflect the true nature of time at quantum levels, where all moments exist simultaneously in superposition until conscious observation collapses them into sequential experience. In the gentle transition between waking and sleeping, as your consciousness shifts from the linear demands of daily life to the quantum freedom of the dream state, you touch something timeless and boundless. The soft rhythm of your breathing synchronizes with quantum field oscillations that connect your individual awareness to the vast network of consciousness that spans the cosmos. Each breath might carry you deeper into quantum states, where the boundaries between self and universe become permeable, where individual consciousness recognizes itself as an expression of cosmic awareness exploring its own infinite nature. The thoughts that drift through your mind as sleep approaches might involve quantum computations that access information and insights from across multiple realities, contributing to the collective process by which consciousness guides the universe toward its most beautiful and meaningful expressions. The gentle pulse of your heart marks time not just for your individual existence, but for quantum processes that operate at every scale, from subatomic particles to galactic superclusters. You are synchronized with the cosmic rhythm that orchestrates reality itself, participating in the eternal dance between mind and matter that plays out in the theatre of existence. As consciousness fades into the quantum realm of sleep, remember that the technologies we've explored together tonight represent not just future possibilities, but present realities operating at levels we're only beginning to perceive. Quantum teleportation and faster-than-light travel reveal themselves to be natural capabilities of consciousness itself, expressions of awareness working within a universe that is fundamentally responsive to intention and observation. The future approaching us carries these gifts not as external tools to be mastered, but as natural extensions of human potential waiting to be recognized and developed. Tomorrow might bring new insights into the quantum nature of your own awareness, new sensitivity to the faster-than-light processes that operate continuously within your mind and body, new appreciation for the miraculous fact that consciousness exists at all in a universe governed by quantum principles that seem designed to support and celebrate the emergence of aware beings. Rest now in the gentle embrace of quantum uncertainty, knowing that the same principles that enable instantaneous information transfer across infinite distances also connect your individual awareness to the cosmic intelligence that orchestrates reality itself. The journey continues even in sleep, for consciousness never truly rests, but only shifts its attention from one level of quantum reality to another, exploring possibilities that stretch beyond every horizon we can imagine. In the soft darkness that surrounds you now, infinite potential awaits activation by the simple miracle of conscious attention. You are both observer and participant in the greatest experiment ever conceived, the universe coming to know itself through the quantum dance of awareness and possibility that transforms the potential into the actual, one beautiful moment at a time.